All right, good morning, everyone. Thanks to those of you who came out on this extremely cold day. It's freezing out there. Very much understand for those of you who decided to stay at home and watch this in the future on YouTube. I get it. No shame here. I kind of wouldn't mind not having to go outside myself, but I made it in. And thanks to everyone who made it out today. Wanted to start by just kind of going over logistics for the next couple of weeks real quick because as you know, there's an assignment due today and another assignment that's going out today, so we're going to chat about those as well as kind of what's coming up since we're getting close to the end of the first half of the class and about to start the second half of the class. So assignment 3 is due today. I've already had a few students ask me if they could have some extra time on it. The answer is yes. Even if you didn't ask me if you can have some extra time on it, the answer is still yes. You can have some extra time on it. I'm pretty loosey-goosey with the due dates on this one. I am still hoping to get assignment 2 back to you this week. Grading wise, I think I'm still on track to do that. I'm going to chat about assignment 4 in just a minute, but before I do, I just want to point out that after assignment 4, or we have 2 weeks basically after this week before spring break. So 2 more assignments after this, assignment 4, which is going to go out today. Assignment 5 is actually probably going to go out on Monday. So I know assignment 4 is not even due yet, but remember, I will not be here on Wednesday, no class. So I'm going to get assignment 5 out the door on Monday. And then after we talk about that topic next week, we're kind of shifting into project mode. So the week right before spring break, we're going to start talking about the project. I'm going to lay out the project guidelines in a lot more detail so you know what's coming. We're going to talk a lot about project management, about how to work in teams effectively, how to work in groups effectively, since that's a big part of the project as well. So we're kind of getting close to the end of the first part of the class and getting ready to shift into the second part of the class. With that in mind, while I am loosey-goosey on the due dates, I want to make it absolutely clear that I won't accept any of these first 5 assignments after spring break. So if you are running late on getting some of them in, totally fine, but I absolutely will not accept them after spring break. That is like the ultimate hard deadline for the first 5 assignments. Once we get on the project, the assignments are behind us. So yeah, just wanted to make sure that was absolutely clear to everyone. As far as assignment 4 goes, that one's going out today, and it should be no surprise to you. That's what we've been talking about the last few days of class, which is refactoring, making code look nicer than where it started. And so you have a choice to make, actually, before you start on assignment 4. There's 2 options that you can take. What I would prefer for you to do, and I hope you at least consider doing this, is to go back and find an old assignment of yours from a prior class. I know some of you, maybe the only prior coding class you've taken is 131. I think that's fine. I think there are plenty of good candidates from 131 that you could choose to use for this particular assignment. I think 247 also has some good candidates that you can choose for this particular assignment. So my preferred option is for you to go back and find some code that you've written in Java for a previous course and clean it up using the rules and the concepts that we talked about in class over the last few days, specifically focusing on those 3 categories: the naming, the methods, and the objects that exist within the code. So hopefully you'll be able to find improvements to make in all 3 of those areas. That's kind of the goal. I understand that maybe you don't have a lot of Java background. Maybe you don't have a good assignment. You just don't have one that you feel is an appropriate fit. I have provided sort of a default piece of code that you can use if you choose not to use your own. So that is already in the assignment repository. So you can check it out. It's actually a little game that I wrote up just this week, actually. This isn't exactly the same as the one that I gave to you. I did make it a little bit different, but it's just like a little dodgeball game. So anyway, yeah. So if you don't have an assignment of your own that you want to select for this refactoring assignment, then you're welcome to refactor the piece of code that I've already given to you. Regardless of which path you choose, right? I want you to make a new branch on this assignment repository, and to submit your code, to submit your assignment, you need to give me 3 things. You need to give me the old less clean version of the code. If you use my code, you don't necessarily have to do that part. I already have a copy of that. But if you're using one of your past assignments, you got to give me the old version. You got to give me the new, cleaned up version, which everybody needs to give me, regardless of where you start. And then everybody also needs to give me a report. I want you to give me, doesn't have to be long, 1 to 2 pages, should be plenty, where you just say something about each of those 3 categories. So the old code, here's what the names looked like for everything, and here's how I fixed it up. In the old code, here's what the methods looked like, and here's what I did to fix it up. And then here's what the old code looked like in regards to objects, and here's what I did to fix it up. Just tell me what you did. Tell me the concepts that you applied to make this code look nice and shiny. I want to make sure you understand I'm not expecting perfection. That's pretty subjective anyway. You might think something looks better a certain way than I do, and that's okay, right? I'm not expecting it to be perfect, but I am expecting it to be improved, better, specifically applying the concepts that we talked about in class. So I'm going to be looking for that especially. Any questions about what I am expecting on the assignment? I know there's maybe a few things I left out, but you can read the write-up. Any questions I can address right now about assignment 4? So that one is officially due next week, but remember, I won't even be here next week on Wednesday. So, the due dates are somewhat fluid, but I do hope you are able to get this done in a reasonable manner. Let me know if you need any help with it. Yeah, and let's go ahead and start talking about what's on our agenda for today. Today's kind of a tying up loose ends sort of a day. So we're going to be talking about a couple of topics that are related to what we've been talking about in the past, general programming tools and techniques as the course is called, but also somewhat related to what's coming up in a couple of weeks, which is the project. So our first topic on the agenda for today is debugging. I'm going to start by kind of explaining the basics. I know that I hope that you all are at least somewhat familiar with the basics. We teach them in 131. I drill them pretty hard now in 131. So I'm not gonna, I'm gonna start by just kind of giving a brief overview of that. But I also want to show you some more advanced debugging techniques today as well. So I prepared a few examples to work on. If you go to the today's date on the course calendar, where are we? Oh yeah, here we are. There is a debug repo linked on today's date on the course calendar. Should take you to this page. This is more of a follow along with me kind of a set of examples. So go ahead and grab this. Just to keep things simple for me, I'm just going to import it the old-fashioned way in Eclipse today. Not going to mess with the command line for now, although I think I might use it a little bit later. Okay, 25. Here we go. And within this repository, there's a few examples. I'm going to start with, of course, the one that's called example 1. We're going to use this to just kind of go through some of the basics of debugging. These examples are all kind of contrived. They don't actually do anything useful or interesting. They're all just set up specifically to show off different forms of debugging. So don't expect them to do anything fun or exciting. If you run this one, we'll see there is an error. There is a good old-fashioned null pointer exception. So the first thing I think to keep in mind before we even get into debugging is like being able to understand these messages. This is something that I also try to stress in the intro class, but especially in this class. Your first instinct to this should be to, if you don't understand what it means, slap it into Google, right? See if Google can tell you what it means. That's what I do. That's what experienced programmers do. You're not the first person that's going to run into this problem. You won't be the last, probably. And even if you are the first person who's happened to run into a problem, it does happen, right? You can still find other people who've had similar problems and maybe use that to help you out of a situation. So don't be afraid to be resourceful. But if we actually want to use the debugger to solve this problem, the first thing that we need to do is set a breakpoint. So a good thing to think about is where the breakpoint should be set. In 131, I get into the habit of just putting it on the first line of the code because I'm usually trying to walk through everything from start to finish. But in a big program, that's not good. That's going to take a lot of time. We got to try and put it close to where the problem is. So, use the stack trace down here to help you decide where those breakpoints should be going. The line at the top is where the exception was, where the exception occurred, and then this is how we got there, right? This is the line they called it. So, depending on how comfortable you are with the code, set your breakpoint at or around the line that's causing trouble. In Eclipse, I do that just by double-clicking over here, and I see the little circle to indicate that the breakpoint's properly set. And then if you click the green circle, it's going to ignore your breakpoints. That's running it in normal mode. So you have to remember to start it in debug mode, which in Eclipse does what's called switch you to a different perspective. I tend to gloss over this part a lot, but it can be a little bit confusing because the whole window changes, right? It's trying to show you different information here. We're doing a different task. I'm debugging. I'm not running the code. I'm not trying to see if the code works properly. I'm actually trying to dig into the code and look at the details. So Eclipse is trying to show me a different perspective. Specifically, when we hit switch, the code stays and the console stays down here at the bottom, but I get my variables window over here on the right, and on my left, I don't see the files anymore. This is my stack. This is my method call stack, and those are very important tools that we want to use when debugging. And so now that we have run this in debug mode, we've hit the breakpoint, and we can tell that it's hit that breakpoint because it's paused at this line highlighted in green, and it's waiting for me to decide what to do next. I have a few different options, and they're all kind of up here on this part of Eclipse. If I hit this green button, it just tells it to go forward, and it will keep running until it either hits the end of the program or it hits another breakpoint. I can have multiple breakpoints if I want to. So this will tell it to continue until it hits another breakpoint. The red squares stop, of course, and then the ones that we care about are usually are these three arrows. The first one is step into, the next one is step over, and the difference between those has to do with method calls. If I wish to step into the method, right, and see how this method runs, then I'm going to use step into. If I don't think that this method call is the problem, or if I didn't write that method, if it's just like a Java, I'm not going to step into system.out.println, right? Like that's not a method that I have control over. Even if there were a problem in there, which there isn't, then I wouldn't be able to fix it anyway. So, only step into the methods that you have written or that you have access to the code for, and ignore the ones that either aren't the problem or you can't modify and access. Anyway, in this case, this method is the problem. Our stack trace told us that. So if we step into it here, or actually, we can actually see that the problem's maybe before this. If I look at the value being passed in for O, it's already null. So if we're dealing with a null pointer exception, which we are by stepping into here, see, O is already null by the time it gets here. So we actually kind of set our breakpoint maybe a little too late to figure out what the problem is. By the time we have hit this line, it's already null. So we need to back up, try and restart our debug, and see what happens, right? This method is supposed to create O, so maybe we should step into this one and see, all right, it creates the new object, it prints out the object, but then, oh, this return statement, that's the problem. And duh, it's the problem. It says return null right here. This, like I said, this isn't meant to be effective code or functional code. It's meant to have silly mistakes in there that we use the debugger to track down. So that's very obviously the problem in this simple example, but that skill of knowing when to use step into versus step over. And then there's actually a third one that I haven't talked about yet called step return, which does kind of what it implies. It says, I don't want to be in this method anymore. I want to get out of this method. I want to return, and I want to go back to whichever method called this method. So it's a way of exiting a method early in the debugger. The step return method is. I can actually show that to you. Wouldn't be a bad thing to demonstrate. So first we step into the make a thing method, and if I walk through, kind of like I did just a moment ago, and say, oh, I see the problem, I don't need to do this anymore. If I hit step return, I just immediately come out of the method. So I don't actually have to go through all of the lines of the method. And get to the end, I can click step return and jump out of it at any point in time. Great. So I use the variables window to help out with that. That's also a very useful thing to see. You can actually, over here, there's breakpoints as well. You can see a list of all breakpoints, including the ones that I've been using for 131. I'm actually a little surprised to see those show up here, to be honest with you, but there they all are. Are there any questions about the basics? So far, I'd say I haven't really described anything that we haven't touched on in intro, but any questions on the basics before we hop into some hopefully newish techniques? Or maybe they're not new to you, but still worth reinforcing, even if they aren't. All right, I'm gonna switch out of the debug perspective back to the regular perspective, because remember, my files aren't here anymore, it's the stack trace. So to do that in Eclipse, I switch out of here. And I'm gonna go to example 2. And the first thing I'm going to do is run it and see what the problems are. And whoop, there's a good old classic illegal argument. Well, it says illegal argument exception. That's interesting. That's actually not a good old classic. I was thinking maybe it was an out of bounds exception, but it does say out of bounds. So interesting. It's kind of both, right? And oh, there we see is where the exception gets thrown. We haven't talked a lot about exceptions, which we are actually going to talk about exceptions. Well, I mean, we're going to talk about it right now. I was going to talk about it later with files anyway, but now's a good time to talk about it too. An exception is an error. An exception is just any error. Anytime you see the red text at the bottom, right, that means that an exception has been thrown, an error has been caused. And this is a category of errors that exist in the code. Other categories of errors would be like syntax errors. That's when you see Eclipse underline things in red because you forgot a semicolon or a parenthesis. And then logic errors is the kind of third category, where the code runs and it doesn't crash, right? It doesn't say, hey, there's a problem, but it just doesn't work. Those are maybe kind of the worst errors to figure out, right? Everything runs properly, but it just doesn't work, doesn't do what you want it to do. If you hit runtime errors like this, you're going to see exceptions get thrown. So exceptions are Java's version of a runtime error. It means a problem happened as the code was running. We could not recover. We had to stop. The program crashed. And we can actually insert those ourselves. And this is an example of doing that. This is an example of saying, hey, we've reached a point where I can't proceed because you've given me a bad value. So I'm going to throw an illegal argument exception telling you that, saying, hey, you gave me an argument to this method, probably this value right here, that is out of bounds, and I'm not going to let you proceed. If we hadn't done this, chances are we would have eventually hit our good old-fashioned array out of bounds exception later on in the code anyway, right? But we did this pre-check to throw an exception first. The problem is that if we consider up here that we have these statements, right, that are running, trying to access various elements of the code. Imagine that we have this giant array. In this example, it's 100,000. And we're doing these accesses to the array in a somewhat random order, right? Perhaps. If this is in a loop or some other repetitive structure, and we try to use the debugger to get there, we run into a problem because now it's going to have to walk through that loop who knows how many times before we actually hit the problem, before we actually hit the exam, the value that's causing the issue, right? So the idea behind this next technique is, let's not set breakpoints and debug that way. Why don't we tell the code to stop anytime there's an exception, and then I can examine the code at that moment and see what the values are, so that I can then maybe do some more targeted analysis, have at least some more information to try and figure out the problem. So what I'm going to do instead is set what's called an exception breakpoint. And let's see, this is a trick. this is where I have to remember how to do this, which is not always an easy thing to do. I may end up Googling it, but there is a, I need to see my breakpoints is what I need to see, which is actually in my debug perspective. Let me go back to my debug perspective, go to breakpoints, and I want to, oh, here it is. It's this button right here. I remember. So let me recap how I got here, because I have trouble remembering how to do this myself, and you've probably never done this before or have done it very few times. So in the debug perspective, there's a list of all these breakpoints. I showed that to you just a moment ago. And this button right here says add a Java exception breakpoint. I feel like it's probably also buried in one of these menus somewhere too, right? But I don't know where. I do know that this button exists though. So if I hit this button, it pops up a list of all of the exceptions that you could possibly run into in Java. And so the one that I'm interested in is illegal arguments exception. So I'll type that in, and now I have a breakpoint set. Anytime an illegal argument exception gets thrown, it's going to pause, just like as if I had set a breakpoint. And I'll be able to look at the code at that moment and try and examine what's happening to evaluate why that exception got thrown. So let me show that to you by stopping our previous example and running this one in debug mode. Now, instead of throwing the argument and seeing everything down here at the bottom, we are actually paused. We are in debug mode. You can see I have the ability to step into, step over, and all of that stuff. But what I really would probably rather do is just look and see, oh, what value got me here? Oh, duh, the index. This is a trivial example. This is not meant to be a tricky one to figure out. It's more of a demonstration of how to set these types of breakpoints. You'll have to use your imagination for when this is, well, not use your imagination. I mean, a real more concrete example would require setting breakpoints in this fashion. I have used this. It's not as common as setting breakpoints and stepping through, but it's definitely handy when you need it. So definitely something to be aware of. And then something else that we can do if we're interested in tracking things, you'll notice that the variables window does show me the contents of the variables, but I can also type in expressions to track as well. So maybe I'm interested in, knowing what the length of the array is. Obviously, I could look at the array variable, but this is, a little confusing to have to sift through all of these values, when I can also just have an expression here. It says array.length. And these expressions can be just about anything. I can also, have index greater than or equal to array.length as an expression. And it says true, and so, oh, hey, now I know that I've got a problem, right? That's another indication that I have an issue. So if there's something that you want to keep track of that's not necessarily a variable, but is just a condition or some other similar thing within your code, these are great. You may also see this referred to as a watch list. Actually, I think Eclipse might even do watch lists, where you can just have it keep track of variables, whether they're in scope or not. You can just always see the value of that variable over the course of the program execution. And then the last one that I want to show you, well, not the last one actually, second to last one that I want to show you in example 3 is a conditional breakpoint. Actually, this is probably a more accurate representation of what I was trying to explain before, where if the problem is occurring within a loop, right, then it can be very hard to debug. So in this particular case, we have a loop, and it's telling me that, oh, it's actually processing arrays, and we want to make sure our arrays don't have zeros in them. Zero is not a valid value. So if we look in this loop and we find a value that is 0, then that's a problem. But look at how this array is created. It's random. There's randomness involved. Anytime there's randomness involved like that, it's going to be tricky, right? Am I going to run into a problem the first trip to the loop? Am I going to run into a problem the 1,000th trip to the loop, the 10,000th trip to the loop? If you try to debug this the old-fashioned way of just using breakpoints, right? I might set a breakpoint on this loop. I know the problem is existing, you know, or is originating somewhere within the loop because it's found a bad value, but at what point? Well, I set my breakpoint at the start of the loop, and we can start stepping through. Whoops. I ran the wrong one, I think. Sorry about that. That was my prior program. Okay. I want to run this one. Here we go. So here I am in the loop. And you can see that everything is okay for now, but how many trips through the loop is it going to take? Right? It's very hard to see where the problem is actually going to be. Eventually, I think if I step through the loop enough times, it'll probably say that everything is not okay. That everything is not okay variable is going to go false. But like, how many times am I going to have to do this before it actually flips? I suppose since it's random, there's also a chance that sometimes it may not flip at all, which is even more confounding, right? Especially if I'm trying to debug. Oh my gosh, is it going to make it all 100? Who knows? So far, we haven't found a bad value. That's interesting. I was really hoping we'd find one. It's going to make me go all the way through. Oh no. Am I gonna? Oh, okay. We made wow. We made it almost all the way till the end. But like, oh my gosh, how painful. That was pain. Hopefully, I mean, maybe it was even more painful for you than it was for me to watch. It was not fun. The good news is we don't have to do it that way, right? We don't actually have to do it that way. We can set what's called a conditional breakpoint. And so, we can do that by, well, actually, I would like to point out that our expressions also maybe kind of help out that I was pointing out before. But what we really need to consider, or what we should really try to, what am I trying to say here? I'm going to toggle a breakpoint, and then I want to apply, yes, sorry, I just had a little blip in my brain for a second there. I'm going to apply my breakpoint, right? But I'm going to say that I only want to pause at this breakpoint under certain conditions. And so in order to do that, I'm going to right-click the breakpoint and go down to the properties. There's actually a few interesting things that you can do here. One is, if you're in a loop, you should also consider this hit count property. That's not going to help us in this particular situation, but if you know that the problem always occurs after 50 times through the loop, you can set hit count to 50, and then it'll pause not the first time through the loop, but at the 50th time through the loop. So that can be helpful if you do know roughly what repetition. But if you don't know what repetition it is and you want to just try and use a condition, so in this case I could say my array at I is equal to 0. I'm telling it I want to stop. I want to pause at this breakpoint when the value at the value in the array is equal to 0, so I can look around and see what's happening. So I'll go ahead and apply and close. If you look real closely, you'll see that the breakpoint has a little mark by it to indicate that it's a conditional breakpoint now. And when I debug this code, we can see that it did hit. I is at 42, so it ran the first 41 iterations with no problems, and then at I42 it encountered a problem. And just to really show the nature of the program and why this is useful, consider, oh, this time it only took 22 trips through the loop before it found a bad value. The next time it might take 64. Yeah, so I got really unlucky that first time with 97. The computer was laughing at me. But yeah, conditional breakpoints are really useful, especially if randomness is involved, if you can't predict when the errors are going to occur. use a conditional breakpoint to help you narrow that down, or a hit point if you do know roughly where that's going to be. And then let's talk about objects. There's a nice trick that I use all the time for objects as it relates to instance variables. So instance variables are unique in that they have a class level scope. They can be used in any method within the class. This also makes it a little tricky to debug because I can access that variable from anywhere, so it's a little tricky to follow how these instance variables are getting modified, how they're getting used. But we can actually set breakpoints on the instance variables themselves, which is a very useful technique. So if I come up here and I double click next to the one that says is hungry, it doesn't look like a normal breakpoint. It's actually saying, oh, it's calling it a watch point, right? So it's not a normal breakpoint. And if we right click and go to the properties, like we did for the last one, the two boxes that are checked here, access, that's reading, and modification, that's writing. So we're basically saying anytime that I see this instance variable being used, being part of an expression or something, I'm going to pause. Anytime I see this instance variable being modified, I'm going to pause. So we've actually got these breakpoints set not on a particular line, but just based on instance variable access. And so if I set that on the is hungry variable, I think I have some stuff. And so I start this in debug mode, and you can see, oh, surprise, surprise, the first time it gets modified is in the constructor. That's exactly where I would expect that to happen. That's good news. But if I hit the continue button, it'll keep running until the next time it's accessed, right? So it shows me every point that I'm accessing this variable. So if I know that this variable eventually ends up being something weird, I can actually trace every time that it's touched throughout my code and figure out when does it get weird, right? Why is it getting weird? And try and use this to help fix the code. So this is a very, very, very useful technique when working with object-oriented programming. I use this all the time. Super handy. Definitely a skill that I would encourage you to try and practice and develop and incorporate into your development routine as well. I'm going to switch to the command line a little bit next, but before I do that, does anybody have any questions about what I've covered so far in terms of the debugging steps? Okay, then we're going to actually do one more debugging example on the command line. I think actually it's important to know that debugging is possible to do on the command line, although, that being said, I don't do it terribly often. It's definitely sort of a niche use case, but one in which if you really need it, you really need it. So this isn't a skill that I'm whipping out all the time, but definitely one that I am glad that I know how to do. Has come in handy in a couple of particular situations, even if it's not an everyday thing that I'm doing. So I'm going to go ahead and open up my command line for this next part. And I need to get to that's not what I wanted. Isn't it called, oh, it's capital C. No? I was trying to get to the repository that has my stuff, but I can't find it for some reason. Where did it put my stuff? Oh, debug repo is what it's called. Okay. Oh yeah, here it is. It's right here. I just didn't realize that that's what it was called. Okay. Perfect. All right. So, if we want to debug some of these codes on the command line, we actually have to do things a little bit differently. First, we have to compile it a little bit differently. So we can't just compile it normally. Remember, the normal way that we compile is with the Java C command. If we want to debug, we have to pass in the -g flag. And the -g flag is what allows us to set breakpoints and step through the code. If you don't have the -g flag, you won't be able to do that if you try to. So keep that in mind. Actually, I need to be careful here. This is another thing that's important to be aware of. These files that I showed you today are in a package. And in the past, I've talked about how packages are similar to folders. In fact, they show up as directories on our computer. But it does matter when you're compiling, especially on the command line. You have to be careful how you compile. I'm in the source directory, and since debug is a package, right, I want to make sure that I'm not inside of there when I'm doing this. I'll run this as debug bug.cat. So when I'm compiling, I say package dot thing that I want to compile. Oh, actually, I'm sorry, it's not dot, it's slash. And then when you run it, that's when you need to use the dot. I got it backwards at first. When you run it, you have to say package name dot file that you wish to run. So I ran that normally, and you can see that it just prints out some statements about my cat Franklin. If I want to run that in debug mode, I have to use the Java debugger, JDB. So I'll say JDB debug.cat. That starts up this program in debug mode on the command line. And now we have to set a breakpoint, or set a breakpoint. That's the first step of debugging. There's a few ways we can do this. I can do it by a line number, just like we do in Eclipse, but we have to type it out. So we have to say stop at debug.cat colon line number. So I'd say stop at line number 30, right? Set a breakpoint at line number 30 and run there until you stop. Or you also have the ability to stop at a method call. So if I say stop at the main method, then it will stop when the main method gets called and let me step through there. Do you have a question?
Yeah. Is there a way to stop when a variable is like a certain value?
Like a conditional, like we saw in Eclipse? Yeah. So there might be, however, you bring up a good point. I don't know if there is or not. I would have to do it, to be honest with you. But it's not as featureful as the Eclipse one, for sure. You are not going to find everything that I showed you in Eclipse in the command line debugger. It's not going to be there. Is that particular thing there? I think it might be, but I'm not 100% certain on that. Again, think about when you might use this. I'm only using this if I don't have, direct access to code that is on a completely different machine, right? So the amount of times that's happened to me in life is pretty small. Normally it's in a repository that I can access and clone and load into Eclipse and debug it properly. That's what I would prefer to do. So regardless, if we get back to debugging on command line, I'll stop at line number 30 and deferring breakpoint. Okay, yeah, that seems good. Did it actually run? Yes, it did. Yeah, so I typed run to start it. And then it set the breakpoint at line 30 and tells me that the breakpoint is hit. And this is the line that it stopped on. So it's showing me the line of Java code that it stopped on. And it's now waiting for me to give it some more instructions on what to do next. So at this point, we can say list, which will tell us, give us more information about where we are in the program, right? So it's showing us more information about where we're at in the code. We can also step. And so now, by default, it assumed I wanted to do step into, so you can see that I am now in the cat constructor, right? If I want to do a step over, I would type next. So step means step into in this case, next means step over. And I think return, no, return's not a command. Take a look at the help. Next, continue, so CONT for continue. Step up is return, yeah, step up is step return. You can see there are a lot of other things here that I haven't mentioned and I'm not going to mention, but, oh, yeah, there we go. I'll type continue to make it run, and it just runs until it's done and exits out. So that's just the very, 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 very basics of Java command line debugging. I'm not going to get into it much more than that. Hopefully it's not something you have to do on a regular basis. I would be surprised if that was something you had to do on a regular basis, but it's definitely good to know when you need it. That's it for debugging. We're going to switch and cover our second topic next, which is about files. Before I do that, any last questions, comments, others before we switch topics? Okay. So then the reason why I like to talk about files, they are used quite a bit, especially on the project. Students ask me, and it's one of the most common questions I've gotten in the past, is because we're not using databases in this class. This is not that kind of class, right? Go take 330 if you want to learn how to set up a database and make a nice fancy website to go with it. This isn't that kind of a class. We're not writing that kind of code in this class. So on the project, the next best thing is files. I get asked a lot of times about how to incorporate files into the project, so I think it's useful to just kind of generally talk about both reading from files and writing to files. We actually talk about reading from files a little bit in 131 in the intro class, but I'll review those concepts, and we'll definitely talk about writing to files, because that's a new thing that most people have not seen before, have not thought about too much until they need to do it, and you might need to do it soon. So I think it's useful to have some examples to look at. There's actually multiple ways that you can write to files. It kind of depends on what it is that you're trying to write. But I think the important thing to consider if you're thinking about making a file as part of an application, before you write anything to that file, you have to decide what the format of that file is going to be. You have to decide. So it's probably just going to be like text, right? Text in the file. But what I mean by format is, if I'm storing multiple pieces of information, right? What order is that information going to appear in? Are there going to be commas in between, right? Stuff like that. You need to know exactly how that information is going to be stored. That depends on the project. That depends on what you're working on, how that information needs to be stored. But you've got to decide that up front, and you got to make it consistent throughout. Otherwise, you're going to have a hard time reading that information back in when you need to do it, which is a common, kind of a transaction that takes place. But once you've made that decision, you then can shift your focus to how to pull it off in the code. And in order to do that in the code, we need to talk about files, which are actually an example of streams, although I don't know that we'll get into streams too much. That's more of maybe a 132 conversation. And then we're going to talk about, for writing, we're going to talk about the print writer class, which I think is probably the most convenient one to use for file writing. I'm going to go into Eclipse. And I don't have a repo for this, so I'm just going to go into my debug repo and make a new class and call it file practice, just to have something to play around with. And probably do things quick and dirty in the main method just for today, just because I'm trying to show off some simple little examples. Let's say I just want to create a file to put a name and maybe an ID number in, or something along those lines for a person. Okay. First thing we need to do is we need to make the file. So that's going to be a file object, capital F. Give it a good name. So like output file, or even output file is not that specific, right? If it's for ID numbers, call it ID number file, or something along employee file or something, right? We're going to make a new file, so we're calling the constructor, and within the constructor we have to give it a path. We have to tell it where this file can be found. But this file doesn't exist yet, right? I think that's okay. I think it will actually create this file for us if that's what needs to happen. So that's okay. That's not a problem. Be careful though. We have to put a path in here. It should not be an absolute path. Whenever you're writing paths in code, especially Java code, but even in your bash scripts, for example, should not be absolute paths. Should not start with slash. And the primary reason for that is consider. It works on your computer, but the second that I load this code into my computer and try to run it on my computer, that path doesn't exist on my computer. It's not going to work. These paths need to be relative paths, which basically just means they aren't going to start with a slash. If you're running in Eclipse, that means that the file is just going to be created right here in the project, right here in the same folder where the project is. Same thing for reading, right? But if there's another folder, you can of course, say source dot, right? Whatever you want. I'll just say output file.txt or something along those lines. And the reason Eclipse is mad at me now is because we have to import this, which we can go ahead and do. All right. Now we can go ahead and actually create our print writer. So print writer is another class that's provided to us by Java. In fact, it would be useful to pull up the API for it. The nice thing about print writer is that it behaves very much like system.out.print or println. So you can actually see that it has println and it has print. So you can, once you create a print writer, you can use it much like system.out.print, except you're not printing to the console, you're printing to the file. And so it'll take whatever you feed into it and print that content out to a file. So going back to the code here, we'll finish constructing this print writer by passing in the file. And just like we did before, we're going to have to import this. And now we get to an interesting part. It's still mad. It's like, okay, well, I constructed it. Everything's fine in that regards, but why is it mad? It says unhandled exception, file not found exception. It's basically saying, what if I can't find this file? What if I can't find that file? You have to tell me what to do. So exceptions in Java fall into two categories. They're either unchecked exceptions, and I would be willing to bet that almost every exception you've seen up until now is probably an unchecked exception. Array index out of bounds is a classic example. Java is not going to try and predict whether an array index out of bounds exception is going to happen. It's just going to say, it happens, right? It's going to wait for bad things to happen and then tell you when those bad things happen. In certain situations, we have what are called checked exceptions. And whenever you use a file, you're going to run into this checked exception. The idea is, oh, hey, you're using a file. It's possible that that file is not there. Either the path is wrong, somebody deleted the file, right? It's very possible. It's outside of our control to some degree, whether the file is even there or not, right? So you have to prepare for that ahead of time. It's a checked exception. I'm going to check for that ahead of time, make sure that you are handling that situation, whether it happens or not. I want you to be prepared for it. So you have two options. You have two options here as to how to handle this. And you can see Eclipse is telling us those two options right now. The first one is to add a throws declaration. I'll show it to you, tell you what it is, and show it to you here. It adds this declaration to the main method. If I was in a different method, it would put it in whatever method I was in at the time. It says that this method can throw a file not found exception. This is bad, usually. This is passing the buck. This is basically saying, well, you told me this might be a problem, but I'm not going to make it my problem. I'm going to make it whoever else's problem, right? So this is usually not the appropriate path to pick. This is usually not the appropriate solution here. So I'm going to Control Z and select the second one, which is surround with a try catch. This is what I always suggest students use when they find themselves in this situation. Try catch is kind of like an if statement, but for exceptions. So the try statement runs. We try to do the stuff that is in the try statement. If an exception does not occur and everything runs and there's no problems, then cool, no harm, no foul. We just skip to the end and move about our day. If an exception occurs, specifically if this exception occurs, whichever one is listed here, then we will catch it and we'll do whatever is in this block. So typically, printing the stack trace is like the bare minimum of what's expected here. You better do at least that. But more importantly, I think it's useful to maybe provide some additional information if you can. Even better than providing additional information would be to, can you fix it, right? Like, can you actually recover from this somehow? It may not always be possible, but if you can, that would be the place to do it. Providing some sort of notification to the user, especially if this is a user-facing application and not for programmers, right? Here, a user's not going to want to look at the stack trace and see what all goes wrong. I need to pop up a window to them and say, hey, I couldn't find the file. Please make sure that it's there, whatever the case may be, before you move on. So, my equivalent of doing that is just putting a print statement for now, because I don't want to get into Windows and UI and all that stuff at the moment, but you certainly could. We're actually not done up here though, because, well actually, are we done up here? We haven't written anything yet, so we need to actually write something. We can do that in the try statement, although I feel a little uncomfortable doing that. I think it's okay, actually. So once we have set all of this up and we have the catch statement, the try catch statement to handle our checked exception, then we can simply print some information to the file. I'll just say, I don't know, this is a made up example. It doesn't matter what we print to the file. Just print some information to the file. And then once you're done, I actually am really bad at doing this, especially even in 131 I'm really bad at doing this. It's important to close it. I always forget to do, oh, what happened to the screen? I always forget to do that part. Always forget to do that part, but it is important to close it. You actually can lose data, you can lose information if you forget to do this. So try not to. Let's give it a spin. Let's try it out and see what happens here. Okay, it may look like, so I did run it. I clicked the go button. It may look like nothing happened, but we need to see if a file exists. So I don't see the file here yet, but if I right click the Eclipse package that I'm in and I hit refresh, oh, here we go. There's now a file that was not here before, and inside of that file I see, yeah, there we go. There's the stuff that I pulled to print. So this is like the simplest, most basic form of getting a file up and running for writing purposes, for printing purposes. I did that first because I wanted to have a file that we could read data in from. That's what we'll talk about next. Any questions about writing before we switch and talk about reading? I mean, it may or may not surprise you that it's basically the same thing in reverse. So, and actually, this is even somewhat of a review, I would say, because we teach you about good old scanner in 131. I'm going to make a new file, actually, I think, for this. I'm going to make a new class. yeah, we teach you about good old Scanner in 131. But the nice thing about Scanner is that if you use system.in, that's the keyboard, right? But if you pass in a file, you can use Scanner with a file. So that makes it very, very easy to read in information from a file. We can set up our file much the same way we did last time by passing in, I'm just going to use the same file that I just created. And then we will create a scanner. And this time, instead of saying system.in, that would be the keyboard, we'll just say the file that we created. Have to import both of these, just like we did in the prior example as well. And surprise, surprise, we have the same problem as before. We have the same we have the same checked exception that we have to handle from before. It wants to know what to do if that file's not there. It's the same answer. It's the same answer as it was last time. I'm going to surround it with a try catch. And then I would put a message here that says file not found. In fact, I'm going to try and trip this catch statement in just a second to show you that part as well. But before I do, let's go back up to this try block. Now that I have this, I would probably, if I want to go through line by line, right? I know there's only one line in my file, but if I wanted to write code to go through this line by line, I would say while has next line system.out.println input file next line. Now this is only reading everything in one line at a time, but I had two values on that line, right? So if I only wanted to read in, either the name or the number, depending on what I want, then I'd have to be a little bit more specific about this. I would have to say read in the next int, for example, if I wanted to get that integer value. That's why the format's important. But just to get things up and running in a simple way, there we go. It successfully read in that value from the file, and I can also come in here and add more stuff. More stuff. More. And if we save the new stuff that I added and come back and run this example again, we'll see that it picked up all that stuff that I typed into the file. Okay, and then just for the sake of completeness, let's try to see if we can, force it to run into this exception here. You'll notice that for writing, it actually seemed a little bit misleading, right? The file did not exist. This file did not exist, but it created it for me. So why is it making all a big hullabaloo about, well, that's just how it works. It may not seem logical. It doesn't really seem that logical to me either, but that's how it works. For the reading case, I can actually see more of a use for it, right? So when I'm reading the file in, if it's not there, it can't just make one up, right? That doesn't make any sense. So if it can't find the file and I'm reading in with the scanner, that is a genuine problem. Let's go ahead and, well, you don't have to do this, but I'm going to go ahead and just delete that file and try to run the reading example again. And we'll see that, whoop, I definitely hit the catch statement. There's that print message that I put in there. So, anything that you can do to give the user more information about what happened, maybe you'll tell them that, oh, I was looking for output file.txt, so that way they know I need to go make that file or figure out where that file is or whatever the case may be. You need to provide them more information and do whatever you can to explain the context of the problem. Cool. What questions do you have? Does anybody have any questions about files or debugging? I know we have 20 minutes left on the talk, but that's it. That's all I have for you for today. So I'm going to let you all get out of here. If you do have homework questions, I'm very happy to stick around, especially if you're trying to finish up assignment 3. I'd be happy to stick around and help you out with assignment 3 with the time that we have left for today. But that's all that I have for you on the agenda for today. We're going to talk about unit tests on Monday. That's a good one. So hopefully I'll see you in here on Monday. We're going to talk about the last homework assignment as well. Enjoy your week. Stay warm. It's freezing. It's so cold.